Hello everyone, I'm Tom MacKay. I'm Strategic SE out of Ohio, and I want to thank you for having me in today to talk to you about ESXi migration. Now, it's very important that we at VMware are helping you, our customers, to move to a ESXi hypervisor model simply because ESX and vSphere 4.1 is the last version of an ESX classic type of hypervisor featuring the Linux Service Console that we're deploying. And so our job right now is to enable you, to help you with all of the resources that are required to give you the confidence to deploy ESXi as the primary hypervisor. So what I'm going to do is I'm going to start with the why ESXi. Why should you be interested in primarily deploying this as the de facto hypervisor in your infrastructure? And since we released ESXi back in 2007, we've come a long way and really listened to you into the kinds of functions and features that you wanted us to add. And I'm going to talk to you about that today and do some compare-contrast against ESX Classic and ESXi. Overall, though, we want to keep in mind some overarching goals. And those would be things like we want to raise your efficiency in your environment. Not only your efficiency in deploying and maintaining, but also efficiencies around process, efficiencies in your operational management and those types of aspects. The other thing we want to do is reduce your management overhead. We want to streamline your management capabilities and make them much easier for you than in a typical ESX Classic fashion. And if we believe that if you do both of those things, you're going to reduce your overall costs, especially operationally, and that's going to make your management happy. So back to the question of why ESXi. Well, let's talk about a few areas that have been traditional that we've had to worry about when we deploy ESX Classic. So areas like patching, reliability, security, ease of deployment, performance, and then back to that reduction of management overhead. So each of these areas have benefits associated with moving to an ESXi model. So historically in patching, because classic ESX was based on the Red Hat Service Console, we were reliant on Red Hat. Every time they released a vulnerability, we had to QA it and patch for it. So that gave us a very inconsistent timeline as to when those were going to become available. And the other side of it was they weren't necessarily cumulative. So sometimes our customers, especially in the days before Update Manager, they had to sort of keep track of these things and then deploy them, right? So believe it or not, over 50% of the patches were for the Red Hat Service Console. And it didn't help also that we had a size of over 2 gig because of that Red Hat Service Console. So when VMware re-engineered this and created ESXi, we actually made it firmware-like or image-like and reduced the size to about 100 megabytes for the pure core hypervisor. So this gives us a number of advantages, being firmware-like or image-like. Very analogous to the way the OEM server vendors have created their firmware and their deployment. The other thing we've done in reliability toward ESXi is to create these dual boot block partitions. And so that gives us an A and a B boot block that we can update one, the other is redundant, and then they switch with each other as you do subsequent updates. And the other thing is when we patch this now, it's cumulative. We don't have to worry about missing a patch or anything else like in the old ESX Classic days. Every patch that's released is cumulative to that date of release. And of course, when we talk about patching, we talk about security invariably. So from the security angle, ESXi, when we were architecting it, really had the security was top of mind in our architectural goals. So because of the size, again, referring back to this smaller firmware-like image size, we have a smaller attack surface for vulnerabilities. We also have added to the number of capabilities over the years within what we might call the ESXi ecosystem, or things, functionalities and features added like SSL certifications, Trusted Platform Module, IPsec, AD authentication. And in the 4.1 release, most recently, we added a feature called Total Lockdown. Total Lockdown being the ability to lock down all users, including the root user, and only allow the encrypted VPX user to access VC and to be able to configure those ESXi hosts. One note on security, we do have security SME specialists, we have security SMEs in the field, and quite a number of security-based white papers if you'd like us to engage with your security teams. And we also have the Security vSphere Hardening Guide, which is available, and we highly encourage you to take advantage of those resources. Ease of deployment next. So we had ESXi embedded from the very start of the architecture of ESXi. So this gives us the ability to work with our OEM partners to primarily embed the ESXi hypervisor directly in the server on flash or USB, so that that can be in there when they drop ship it to the customer, to you, to be able to boot up and host VMs almost immediately. So much easier to deploy in your infrastructure. Some of the other features we've given here, or we've created, are the ability to support pre-boot execution environment. More recently, boot from SAN. And we also now support scripting for install, like we have forever on ESX Classic. We now make that capability available also on ESXi. From a performance standpoint, many of our customers have actually seen a tremendous performance increase by just moving from ESX 3.5 to vSphere 4.1. But we also see things like faster boot times. Faster boot times, and we've also added some additional functionality like support for jumbo frames for network throughput enhancement. And finally, reduction of management overhead is really something that we focused on with these new tool sets that we're providing around scripting, like the VMware vSphere Management Assistant, which is a CentOS virtual appliance loaded with tools, which I'll talk about in a few minutes. The vCLI and PowerCLI scripting environments. And then, of course, sharing the vAPIs with our partners to be able to allow them to participate and make their own products to help you in management and deployment of ESXi. So these are some of the reasons and the benefits that you can expect by moving to an all ESXi hypervisor architecture. And so next, I'm going to talk to you about the architecture and show you the similarities and the differences in how we built ESXi. This next section I'd like to talk to you about is an architectural discussion and really a comparison between ESX Classic and ESXi. I find that when I draw this out in a graphical way, it's a little bit easier to understand how we've transitioned from ESX Classic to ESXi from an architectural perspective. So how I usually start this is I'll actually draw a physical or graphical representation of the VM kernel and then make some addendums here like the device driver here, that the device drivers that reach down into the hardware. Then I'll create a storage stack, a network stack. Then I will write a representation of the VMFS file system, vNICs, vSwitches, okay? And I'll create a box that represents the resource scheduler, where we have CPU and memory being taken care of. I'll create user mode API. This is where the user world is also referred to sometimes. And we'll have a representation of VMXs. I'll create a couple of virtual machines here. with their virtual machine monitors. And so at this point, I can label this either ESX or ESXi, because here's where we come to functional parity or functional equivalency. We can look at this basic construction of the VM kernel, and this could either be representative of ESX or ESXi. So at this point, what I'll do is diverge a bit into showing ESX and how it has looked in a classic sense. So here we have the service console. This is the Red Hat base service console, also referred to often as the COS, or the console operating system. So I can create a box here that represents third-party agents, usually for backup or management. But you can also have other agents in here that you may have written as a customer or supplied from another third party. And then a box that represents where the VMware agents reside, things like VPXA, hostd, or HA, for instance. So this is the service console that is really the management interface into the VM kernel. And so how's an administrator, how do you interact with this environment? Well, I can draw out my happy little administrator here. And so he's going to interact with this environment primarily through a number of tools and techniques. Well, one would be he'll be on the local console using a command line interface, primarily through connect by SSH. He may actually have some way to get in also through a VPN or some sort of a jump box. But either way, he's going to be using things like the VIC, VC, command line interface, SSH, maybe using things like PuTTY or WinSCP or other third-party tools to access and interact with the service console. He may also be running ESX top for diagnostics or troubleshooting purposes. So this is kind of a model of what we look like in the ESX realm. So what does it look like now from an ESXi perspective? So I'll draw out here a few boxes that actually represent integration into the VM kernel. So consider this green area being part of or integrated with the VM kernel. The first thing I'm going to talk about is SIM, or the Common Information Model. So the Common Information Model is a DMTF open standard that describes a framework for how agentless hardware monitoring is done and how some of those managed elements actually interact with each other. So you have the hardware down here that can feed up through to what's called a SIM provider and a SIM broker. And so the hardware, which is enabled either at the ASIC level into the hardware itself, can feed back information about its health or status through this provider into the broker and then out to a consumer. So as an example, vCenter is a consumer of SIM-based information. It could also go out here to an OEM management console. And this is typically done by SIM-XML or WS-MAN protocols to feed this information back. But we have an open standards-based framework here that allows us to move from an agent model into a non-agent or an agentless model. We've done the same thing with the VMware agents. So the VMware agents are now incorporated into the VM kernel. So hostd, I can write here, VPXA or HA. Again, moving them from a Linux-based service console directly into the VM kernel. We do the same thing with the infrastructure agents. So you may have a representation here of NTP, syslog, DNS, or SNMP. And so now we can go directly from the kernel out into, say, an NTP server for time sync. We can go out to enterprise logging by having a syslog direct out. And then even if we have legacy management connections that are based on SNMP, we can have that also talk out to those legacy management systems. And finally, DCUI and tech support mode. The direct console user interface, where you'll have local console access and configuration. And then tech support mode, which is now fully supported for user interaction and for scripting hooks as well. So once again, I'll draw my little guy here, my happy administrator. And so what kind of tools have we provided the administrator with now in this new paradigm with ESXi? Well, one of them is the VMA. So this is the vSphere Management Assistant. The vSphere Management Assistant is actually a CentOS-based virtual appliance loaded with tools to be able to manage and deploy and maintain the environment. Some of these things are the vCLI scripting environment, which also features our ESX top. So this would be analogous to the ESX top that we've typically done in the service console. This is a remote version of it that's executed from the vCLI through the vSphere Management Assistant. We also have the Perl SDK environment, as well as VMware tools, an authentication component, VI FastPass, and a logging component, VI Logger. The other thing my administrator can take advantage of are things like the Power CLI scripts that give you a view into the very powerful object-oriented PowerShell Windows scripting environment. So the difference here is the vCLI commands give you about 29 commands, where the commandlets in Power CLI are well over 245 commands and growing every day. The other things we can leverage here are AD authentication, as I mentioned earlier, direct console user interface, and tech support mode. And that tech support mode can be launched either remotely or locally, and it also gives us the ability to do SSH and to hook in scripting through tech support mode if necessary. So again, whether we're local or remote, as long as we have access to the vSphere Management Assistant, or we can actually go directly from our administrator up into tech support mode, this gives us quite a view into how we can manage in this new paradigm of ESXi. So as you can see, in this graphical sense, we can now realize where each of these parts are plugged in and how we transition from the ESX Classic world into the ESXi world, giving us this new paradigm of management that is going to increase your efficiency and reduce that management overhead. So now that we've looked at the architecture, let's go now talk about the functional management equivalency of what we have between ESX and ESXi. So under ESX, we had management agents and the service console. Under ESXi, we have agentless API based. Under ESX, hardware agents lived in the service console. Now they become agentless, SIM-based. Command line interface occurred in the service console, but now we have the remote. The VMA, the vCLIs, Power CLI. For diagnostics and troubleshooting, now we have the direct console user interface and tech support mode. And finally, for the infrastructure agents, now we have native agents. So intp, syslog, etc. So really this is how we can make a comparison here as to what we had in an ESX model versus now what we've transitioned to in an ESXi model. So you can see the functional parity between ESX and ESXi. So now that I've talked to you about many of these new paradigms of management and the new tool sets and things, what's the call to action? What would we encourage you to do? Well, if we look at this as a call to action in the transition plan, we think you should deploy ESXi now. With this term functional parity, it really brings it together so that we think that the primary hypervisor you should be deploying in vSphere 4.1 is ESXi. The other thing would be to check with your backup and management vendors and other third-party vendors to make sure that they are completely transitioned over to an ESXi embedded model. The third thing we'd like you to do is to really learn the tool sets. Become familiar with all of the new scripting interfaces, the VCLI, the VMware vSphere Management Assistant, the Power CLI, because those are going to make your life so much easier and streamline a lot of the management things that you would normally do. Okay, the fourth thing is really take advantage of online resources. We have a number of things available. We have the ESXi Info Center. We have the migration white papers. There are a number of classes offered by VMware Education, and plus there are a ton of great third-party sites like William Lamb's site, Alan Renouf's site, as well as our own Carter Shanklin. So we have a lot of access for all of our customers. And finally, ask your partner, SE or VMware SE, for help. We are ready and willing to help you, to enable you, to get you familiar with all of these new tools that you may be unfamiliar with. But really, when it comes down to it, VMware wants to encourage you to get used to the fact that ESXi is now our primary hypervisor. Convergence is in 2011, and the next version of ESX is going to be exciting, and we just want to help you get there and deploy as quickly as possible. So if you have any questions, if you have any needs, please contact me or any of your SEs that are out there. So thanks for your time and attention. Appreciate it. Good luck.